Hello, today we are talking about antiderivatives using the power rule. So before we start, we're going to talk about what notation all this stuff is. So for the first thing, we have this entire thing, and again, this is the entire thing here, is called the integral. Now the reason that's called the integral is we have this symbol here, this one, and that is the integral sign. And along with that, we have what's inside of that, and that is here, my x to the fifth is my integrand. Then we also need to know what variable we're using, and we have this thing here called our differential. And within the differential, we have this variable here. In our example, there is an x. So that's the variable that we are using. We're going to integrate with respect to that variable, and our answer will be in terms of that variable. We could have a t there, we could have a b, we could have any variable you wanted. So let's talk about our notation and what this actually means. The derivative and the indefinite integral are inverse operations, which means they undo each other. So if I have that g of x is the antiderivative, or the indefinite integral, of f of x, that is if and only if the derivative, okay, again, here's our derivative, of g is the same as f of x. So again, an antiderivative, which is an indefinite integral, is basically the inverse of our derivative. So the next thing I want to talk about is this constant of integration that we will be discussing. And to talk about that, I'm going to look at our little diagram that is right here. Now on your paper, it's not as clear. Up here on the screen it is, because you can see the colors that were used. But if we look over here on this side, we have x squared, we have x squared plus 3, we have x squared minus 6, we have x squared plus 4. If you take the derivative of each of those, even though they're different functions, when you take the derivative every single time, you're going to get 2x. It doesn't matter whether you have that constant there or you don't have a constant there, the constants being the 3, the negative 6, and the positive 4. When I take the derivative of a constant, it is 0. So we need to take this in consideration when we're starting over here with our 2x and we do our indefinite integral or antiderivative, that we could get any number of these functions. So to deal with that, basically what we're going to do is every time we take an antiderivative, we are going to write plus c at the end, which simply means there could be some constant here. The constant could be 0, the constant could be positive 3, negative 6, it could be 82. We don't know, but there should be the possibility of having a constant. So again, just in keeping with this, there are an infinite number of functions that could have the same derivative. So because of that, we are going to write that plus c. Now, this, when we do our plus c, that's called the general solution. And that's the one that has infinitely many solutions. Eventually, what we'll also do is we will find some particular solutions. In order to do that, we would have additional information about our function, the indefinite integral or the antiderivative, that we could use to actually find that plus c value. Now, for right now, all we're going to deal with are general solutions, so we will not be talking about particular solutions right now. So let's go ahead and look at this power rule. And again, antiderivatives are indefinite integrals, and they're infinite because of the plus c. So here's our rule, and again, we learned a power rule for derivatives. So basically, we're undoing everything that we would do when we were doing a derivative. So let's look at this. I have this exponent here, and that's a number. So I have x squared, x cubed, x to the fourth, something like that. What I do is I add 1 to the exponent. But let's think about what were we doing when we were taking a derivative? We were actually subtracting 1. So this is really the opposite of what we did when we took the derivative. And you don't need to write this down. I'm just writing it down so you can see that we're actually doing the opposite here. In taking a derivative, we subtract 1. In taking the antiderivative, we add 1. Now, if you think about when we're taking a derivative of a power rule, we multiply by whatever our exponent was. So in the antiderivative, we're dividing instead of multiplying, and we're dividing by the new exponent. And again, that's the opposite of what we were doing when we took a derivative. So let's go ahead and let's try some of these. So in example 1, we have x to the 5th. So all I'm going to do is I'm going to say, okay, I'm going to have x will now be to the 5 plus 1, that's 5, sorry, and then I'm going to have 1 over 5 plus 1, and then I'm going to have a plus c. I do want to go ahead and simplify that just to see what we have. And basically we have 1 over 6 times x to the 6th plus c. And we can also write that as x to the 6th divided by 6 plus c. All of those are the same. So in our next one, we need to write this calculus friendly before we can even start, because right now I don't even have an exponent. So this is the indefinite integral of x to the 1/2. And now that I have it written with an exponent, we can go ahead and do the same thing. I am going to have x to the 1/2 plus 1, and I'm going to multiply that by 1 over 1/2 plus 1. And then again, I'm going to have that plus c, that constant. If we were to simplify that, I would have 1 over 1/2 plus 1 is 3/2 times x to the 3/2. And again, there's several ways we can write that. If we were writing it back the way we started, then that would probably be 2/3 times the square root of x cubed, which could also be written as 2/3 x square root of x plus c. And again, you don't need to simplify that unless it is a multiple choice question. The next one does have an exponent, however, it's not written calculus friendly yet. So I need to rewrite that so I don't have anything in a denominator, so that will be x raised to the -2. And again, I'm just following my rule, just adding 1, no matter what that exponent is. And then from there, I am simply simplifying. And I believe the constant in front, 1 over the quantity -2 plus 1, is just a -1. So I'm just going to write that as a negative. And then my new exponent is x to the -1. And again, if I wanted to, I could rewrite that the way I started in terms of a fraction. So that's your basic rule for the power rule. Let's go ahead and look at more properties. And these properties I think are fairly intuitive. If I have a constant times a function, I can just pull that constant outside of the integrand so that I can go ahead and just multiply by that number in the end. Additionally, if I'm adding two different terms inside of the integrand, I can write that as two separate integrands that I'm going to deal with. So again, I'm going to go ahead and rewrite each of these using these rules, and eventually I don't know that we will need to do that. So I can pull the 7 out of the integrand that has to do with the x squared, and then I can pull the 4 out of the integrand that has to do with the x, and then I have just this 3 left. And then I can take the antiderivative of each one of these. So for that first one, the 7's going to stay there, and then the antiderivative of x squared is x cubed times 1/3. And then I move on to the next one. 4, I have x. There's not really an exponent there. It's really x to the first. So that's going to be x squared and times 1/2. And then this last one here, I have 3 times the indefinite integral of dx. basically I just kind of think about it. What would I have to start with so that when I took the derivative I ended up with 3, and that is just 3x. And again, can I simplify that? Absolutely. And do I have to simplify it? No, not unless it's multiple choice. So let's look at our next one. Our next one, we do need to rewrite calculus friendly before we can start. And we have that that is 2x to the negative 2. And then we have this integral of x to the 1/3. I forgot my dx on the first one, sorry. And so from here, again, I can pull this 2 out. And once I have it rewritten, I can go ahead and find my antiderivative. So again, that 2 is going to stay there. I'm going to add 1 to my exponent, and that gives me a -1. And I'm going to have a -1 out front. And then I'm going to subtract x, add 1 to 1/3. And again, sometimes we have to deal with our fractions. 1/3 plus 1 is really 1/3 plus 3/3, which is 4/3. And I have a 1/4 right here. This looks terrible, and I apologize. And then plus c, and I'm going to rewrite because I can't see this. So -2x to the -1 minus 3/4 x to the 4/3 and plus c. So please bring any questions you have to class, and I hope you are comfortable with the antiderivative using the power rule.